Another topic that LPIC certification demands us to understand is the concept of logical volume management, which we can assume, you can roughly say that logical volume management, or LVM, it is comparable to SAN. Now the difference is that SAN is primarily used for network storage. Where we have many devices, and those devices through network, through optic fiber cables, they get connected to SAN or maybe copper cables, and SAN as a central repository serves the data to those devices. It could be hosting maybe databases, or maybe web pages, or maybe FTP data for the users. So likewise, we can create LVM for a single system. Now what LVM does, it is kind of, you can say that it adds on the functionality of RAID, which is redundant array of inexpensive disks. So what LVM does is that, let's assume that we have got this disk over here, and another disk maybe, and then another disk. So what we do is that first let's just call it, let's say this is disk 1, this is disk 2, and this is disk 3. So the first step that we do, or LVM does, is that it creates a physical volume against each of these physical devices. Next thing is that we create a group volume, so that we bring all these physical volumes, normally called as PVs, they are put together into GV, or group volume. And then this group volume, it is managed by the logical volume manager, or LVM. And on top of that, our file system, it could be anything like maybe Linux or extension 3. In case of we are using extension 3 file system, that file system resides on top of this LVM. Now if we compare LVM with RAID, then RAID also does the same thing, that it can, if we are talking about RAID 0, it can take these disks and kind of combine them, or increase the capacity of the total volume by combining these 3 disks into one logical unit. And also RAID 1 provides us this functionality of mirroring, isn't it, where if we have got one disk and another disk, then the data is replicated onto either of the disk, so that either disk gets failed, we have still working data on the other disk. Similarly, we have another level of RAID, which is RAID 5, and what it does is that if we have multiple physical disks, then out of these disks, one disk, let's say this one, it holds the parity bit for all these devices. So if any of the device gets failed, let's say if any of these devices from this RAID array gets failed, that data can be recovered using the parity bits. But RAID is good, there's no doubt about it, but what RAIDs fail to perform is the automatic resizing. Like we can increase the size of the volume, or maybe decrease the size of the volume on the fly without any loss of the data. That is an awesome functionality that is provided by LVM. Likewise, RAID fails to provide any backup of its logical volume. There is a functionality of snapshot in LVM, which what it does is that we can take a snapshot of the complete volume, and then we can reinstate it in just couple of moments. So really a quick way of recovering our data and our volumes, as compared to another facility which is available, which by the way is not there anymore. Now what industry best practices say is that since RAID is also good as it provides redundancy, and let me just clear this slide and start a new one, so that I can further elaborate on LVM and RAID. So in the industry, how LVM is usually implemented is, let's say if we have got maybe multiple disks, maybe we have got 10 GB, 20 GB, 30 GB, so 10, 20, 30 and 40 GB hard drives. What we can do is that, let's say we make a volume out of these using RAID, maybe RAID 0, and we have another inexpensive disks, maybe say 50 GB, 60 GB and 40 GB. So we make another logical volume using RAID 0 of these disks. And then what we do is that on top of these RAIDs, we make RAID 1 using these two, so that if any of them gets failed, the mirroring concept of RAID 1 kicks in and our data does not get lost. Now this will be one logical volume of RAID 1. What we can do is that we can create, let's say, 2 or 3 logical volumes, and these volumes will act as a single point of single device, I should say, single device or single storage unit as far as LVM is concerned. So we will point LVM to this logical unit as if it is one physical device. Likewise, we'll be pointing this as another and this another. So it will be like LVM will manage RAID from a broader perspective. Of course, it will not be managing it. It will be managing the volumes that have been created by RAID. But we can say in a rough manner that RAID will be governed by, or storage provided by RAID will be governed by the LVM. Initially, the LVM configuration and its concepts look a little bit complex, and to be honest, they are. But the functionality that they provide, like I just mentioned, that resizing of our volumes, reducing them, taking a snapshot, they are so much powerful and helpful as far as life of a system administrator is concerned, that once you get hang of LVM, you will just love it. So now let's see a couple of commands that how we can create a logical volume management. So here we are, I'm on my Ubuntu box and let's just say I've also inserted a pen drive of 8 GB. So let's see what's in there. So if I type in, let's say, df-h, just hang on for a while. So this is the drive that I've inserted in, and we will create logical volume on this one. Just remember this one, that it is SDB drive. So I type in sudo, then fdisk, and afterwards the name of the drive, which is SDB. It asks for the password, I give it that, and if I do M to see the possible commands or options, then these are the options that are available. I'm going to use T because we want to create a partition. So I do that, and here's a list that we can see by using capital L, and the option that we want to choose is Linux LVM. Its code is 8E. Based on this code, this software that we are using, which is fdisk, it will create the partition that is compatible with Linux LVM tables. So I type in 8E, and it says that system type of partition 1 is now changed to 8E. Now let's see what is written over here, which is this one. Now let's save this partition type on the disk by typing W, and it says that it is indeed have been written. Alright, so we see the error that it is giving that the resource is busy. So let me just unplug the device and unmount the device and then do the process again. Okay, so this time the system has written it because I just unmounted the drive using command umount, and then use the fdisk command again and made the partition compatible with Linux LVM. Now the command to create LVM is first, as I mentioned, that we need to create physical volumes. So we need to run this command using root privileges. So I type in physical volume, and afterwards, so I type in sudo pvcreate or physical volume create, and then the name of the partition that I want the volume to be created on. So we see that in the earlier step I had created partition number 1 to be compatible with Linux LVM. So I use that one to create the physical volume or logical volume on. So I type in div/sdb1 and it says that the physical volume has been created. Now we need to create the group volume. Remember that physical volume, after that group volume. So we do that by typing in sudo command and then volume group create vg create, and then we need to name it. Let's just name it maybe vg group. So vg group, and afterwards we need to name the physical volume that we just created, which was div/sdb1. So once we do that, we see that a group has been created successfully. Now once the group has been created, we can also see it whether it is created or not. So I can type in sudo and then vg or vg display, and I press enter, and we see that indeed a volume group has been created which we named vg group, and its format is LVM2, and also the group size is 7.5, but allocated size is 0. So we did not allocate any size. So let's do that. Let's just delete this group first. I just wanted to show you this thing. So to delete the group, I can type in sudo then vg remove and then the name of the group, which is vg group. So now the group has been deleted. Now let's again repeat the command, and this time what we do is not only that we create the vg group, but also we allocate space to it. And you know what, let's go this time. So let's just create it one more time, and now let's just create logical volume, and in logical volume we allocate the size, that what should be the size of that logical volume. So I type in sudo and logical volume create, and then I define that what should be the group that should be used, which in this case is vg group. Then what should be the size of the volume, that is what I was talking about. So let's just give it 100 MB at the moment. And then what should be the name of the volume? So let's call it L volume, and also the physical volumes that we had created earlier, which were dev/sdb1. So once I press enter, we see that indeed a logical volume has been created. Now this volume has been created. We can define now file system table on top of that by using make file system command that we'll see in another lecture. But we can also add another hardware into it, and by that we can use the command, which is, let's say if I've got another hard disk or maybe another device that is providing storage facility, I can add it into this group by typing in sudo then volume group extend, and then the name of the volume group that we have just created, which was vg group, and then the device. Let's say that device that I have added is SDD. So once I do that, this device will also be added into the vg group, and in return extending the capacity of our volume group. Similarly, we can also extend the logical volume, like at the moment it is taking 100 MB. If I type in vg display, we see that it is taking at the moment 100 MB, this logical volume that we have created. We can extend it by typing in sudo and then logical volume extend, and again the switch is -L, and this time let's increase its size to 150 MB, and then the path of the logical volume that we created, which is in dev, then vg group, and then the name of the logical volume that we created, which was volume. So once we do that, we see that It gives us the message that indeed the logical volume physical extensions has been added, and now the size has become 152 MB byte. Now if I press VG display, we see that now the allocated size is 152 MB. So really a great tool. It is embedded in software and it is very powerful in managing our disk and our storage. And although it's fairly new technology, but industry is adopting it at quite a fast pace. So that's all there is to it as far as LVM is concerned, that it provides an abstract layer to manage our hardware devices. And we have also seen that how we can use different commands to create first physical volumes, then volume group, and on top of that the logical volumes. So I hope you have liked the video, and I would like to thank you for viewing.